All right, so this is going to be a little bit of a summary of what we did last time about infinite limits, meaning limits that end up going to infinity, vertical asymptotes in particular. So in general, these are some limit properties. If we have a limit so that we have the limit as f of x, as x goes to c of f of x, like this one right here. All right, like this one right here, the limit as x is going to c of f of x is going to some infinity, positive or negative, doesn't matter which. And we have a limit of g of x, and it is going to some number, L, okay? So L is a real number and c is a real number, it says. Right, if I have two things and I have some function plus or minus some other function, well, then it turns out we've got something like in plus or minus infinity plus L, because of the limit properties, you can do this part, then this part. So if you're taking some infinity and adding a number to it, it's still going to go to infinity. Or if I take negative infinity and add a number to it, then it's still like if I have negative a billion, million, trillion, gazillion, that's not a real number. But if you have that and you add a number 10 to it, it's not changing the fact that it's really living huge, okay? So and that doesn't matter if L is positive or negative, it's doing that. All right, so what if L is positive and we have F times G? Well, we know from our limit properties that we can say, all right, we can do the limit of F as x goes to C times the L. Now, it says out here L is positive, so if I have plus or minus infinity times L, well, if I take a big, big number and multiply it by a number, it's still a pretty big number. All right, so I'm ending up with plus or minus infinity. Same deal here. If it's negative, if it's positive or negative, infinity times L, it is going to flip the sign, though. So if L is negative and we had positive infinity for F, it'll be negative, then it'll be positive the other way. If it's negative infinity for F times a positive number, times a negative number for L, then it will end up being positive. The other deal we have here is that if f of x is some number, g of x is going to some number L, and f of x is going to some infinity, this whole thing is going to be going to 0. Let's think about that for a second. So I've got a number, any number, pick a number, 10, 100, doesn't matter, 10 or 100, and I divide by an enormously huge number. Think about a fraction. 1 over something really huge is practically 0. So the limit I'm getting towards 0 as this is getting bigger and bigger and bigger and bigger. That's what infinity means. This whole thing is getting smaller and smaller and smaller and smaller, close to 0. So in other words, if I have any number over infinity, it's 0 if I'm talking about limits. All right. What if I have to find the limits then of some combined functions? So I've got this guy minus that guy. Well, this part is easy. It's minus 10 because I put in 5. It's just minus 10. This part, if I put in 5, I get 4 over 0. So I don't get a number. I get a vertical asymptote. I know I'm going to positive infinity or negative infinity. It depends on if I'm going from the left or the right. So let's just change this problem for our sanity to from the left. So if I pick some small number just to the left of negative 5, so maybe positive 5. 5, so I'm picking it to the left, 4.9. Pick 4.9. If I do 4.9 squared, that's something less than 25. So I have something less than 25 minus 25. This is a small negative number if I'm to the left. And again, I changed this problem to just have that to the left. I'm going to approach from the left. So this guy is negative infinity minus 10. Overall, I got some huge number that's getting huger and huger and huger negative minus another number. It's getting even more negative. That's negative infinity. And that's how you can logic through that. Now, what if it was from the right-hand side? Okay, so now I'm doing the limit as x goes to 5 from the right. So then I end up having 4 over some small positive number. That's going to positive infinity. And this part still minus 10 when I put in 5. So I have infinity, some huge number that's getting huger and huger and huger, and I subtract 10 off of it, still a huge hunk of number. Now, what about this guy? All right, now it only is going from the right, so we only have to take care of one. All right, so if we think about putting 3 in, I get negative 12 on top. And on the bottom, I get cosine of 3 pi over 2. Well, cosine of 3 pi over 2 is 0. Think unit circle. It's down here. Cosine of 3 pi over 2 is 0. So I have negative 12 over 0. But remember, I'm not really getting to 3. I'm getting close to 3 from the right-hand side. So let's think about the graph of cosine. I can think about it in the unit circle, but I might think it's a little confusing to you. Cosine looks like this. All right, and at 3 pi over 2, we're at 0. So if I'm talking about going from the right-hand side, okay, the values are positive. As I get closer and closer, my values of cosine are actually positive. This is some positive little number. So the whole thing, I've got a negative number over a positive little teeny number. I'm going to negative infinity. I would like to first of all ask you to please change this problem to be from the right, just so that we don't have to talk about both sides. All right, so we're changing that limit to be from the right with a little plus sign there. It's not showing up very well on my screen. So if we first substitute in, we get negative 4 over negative pi over 2 squared all over tangent of negative pi over 2. Now, the top, if you do some math, we've got negative pi squared, which is just pi squared, and over 4, so that 4 and the 2 squared is going to be 4. It's going to cancel. So I have negative and then pi squared. So remember, that's going to be negative 4 times pi squared over 4 when we do the squared. And so these 4's are going to cancel. It's going to be negative pi squared. Okay, and on the bottom, tangent is actually not 0 there. I just wrote 0, but it's actually not. If I think about the graph of tangent, at negative pi over 2 and at pi over 2, it has asymptotes. And tangent looks like that. Tangent is actually, and on this side, it's going to positive infinity. Tangent is actually going to negative infinity as we approach from the right. So I had you change that. So it's going to, I just put positive infinity. I'm having issues here. We're going to put negative infinity. All right. So if I think about this, I have some number. 3.14 squared, so something about 10. I have like about negative 10, about, over some negative infinity. Well, what's going to happen? I have negative divided by negative. It's going to be a positive number. So I have 10 divided by enormously large number. I'm going to be 0, period. Now, if I had done that from the right, and I'm talking about going, from the left, and I'm talking about going to positive infinity on that side, and I had this. So that would be as if I'm going from the left. So that little guy would be a negative right there. So it would be positive now on that side because I'm going to positive infinity. Well, what would happen? Now I've got negative infinity over negative pi squared over positive infinity. This is going to be a negative number. And I've got pi squared, about 10. So I've got about negative 10 over a really huge number. Okay, so I'm dividing a negative number by a really huge number. I'm getting to be a really small number. It doesn't matter that it's positive or negative. That whole thing is going to 0. So honestly, it didn't matter that I did the plus or minus, but I wanted to think about it from both sides so you guys could do that. So this whole thing is going to 0 when I'm talking about this whole function. All right. So to make a quick summary of what we've talked about so far, both this time and the last few times that we've been in class. First, when you want to do limits, you always substitute. You always substitute. If there's division by 0 or infinity, we need to do some more work or some thinking. If we get 0 over 0, that's called an indeterminate form. We're going to try things like factoring, rationalize or simplify fractions, use any special limits. We know we're actually going to talk about that in a second. The squeeze theorem is in particular what we're going to talk about. If you get some number over 0, the limit does not exist, but you're going to either positive or negative infinity or both, depending on we're talking about a vertical asymptote here, generally speaking, and then we have to do a little thinking about, we have a number over, is it a positive number or is it a negative number, a little positive or a little negative? This guy, if we get some number over either positive or negative infinity, I've got Any number, 100, divided by a really enormously huge number, we're going to 0. It doesn't matter if it's a positive, really huge number, or negative, really huge number. A little number over a huge number is getting smaller and smaller and smaller. It's getting close to 0. We're still going to address this infinity over infinity. It's not necessarily 1. And that's what we're going to address in the next video. And it has to do with dealing with horizontal asymptotes. All right. So until the next one, good luck.